Okay, we're going to go through, first of all, doing neutral atom Vsepr for regular students. It's also recommended for the advanced students so they can kind of get used to what we're doing. Okay, these are going to be covalent compounds. I'm going to do the simpler ones first. And again, all we're doing is just going to be drawing the structure and using this formula. The formula itself is pretty easy to use. The first one I'm going to do is one that's relatively easy. I'm going to do H2O. And I will throw some terms in there just to kind of get you used to it, especially with the regulars. When we go into classifying, these are things you're going to have to know. Okay, first of all, I have the structure, H2O. Well, the first thing I need to do is use this formula, and I'm going to start with my H. Just don't worry about this part because we're going to be solving it. First of all, hydrogen has one valence electron. It's in the first group. Oxygen has 6 valence electrons. It's in group 16. Okay, so what we have to do is we need to try to make this equal to 0. Valence electrons, this minus my lines and my dots, I got to try to get that equal to 0. And it may seem rather easy. It is actually. You just have to pay attention to going from the outer to the inner. My inner is going to be the least amount. So basically we're just going to draw it this way. Don't worry about the way I have the structure. This is the normal structure of water. Okay, so first of all, I'm just going to go ahead and put all my dots around here on my outer ones, but I don't need them. Hydrogen's always going to need just one line. Why? Because 1 minus 1 equals 0. That is my objective. Now, how do I make oxygen equal to 6? Well, first of all, now I have 2 lines going to it. And how am I going to make that equal to 0? Well, I'm going to have to add 4. So I'm going to have to add 4 dots to make this equal to 0. Just remember, dots are going to go in pairs. I have to have 2 for each one. So when I'm looking at this, my second number is never going to be an odd number. It's always going to be an even number. So we have my structure here. This is actually the correct structure. And it's going to be based on formal charges. This one, again, I have to go through some of the classifications to get started. But these parts here are actually considered making this thing polar. If I have dots around my central atom, that is called a polar molecule. And we're dealing with covalent compounds. Those are considered polar. So kind of take a second to look it in. Perhaps maybe ask some questions in the future. We are going to have to classify shape, but I'll kind of show you how to do the shape part. We're not going to worry about it at this point. So we're just worrying about the polar part first. Now let's go ahead and do a second one. Let's say I have CF4. Again, we're kind of going with, these are actually neutral compounds. You notice there's not a charge there. So these are all considered neutral. Again, my lowest amount, let's do the valence electrons first. We have carbon, we have fluorine. Carbon is in group 14. It has 4 valence electrons. Fluorine has 7 valence electrons. It's in group 17. So if you're looking at a periodic table with those numbers around, you know, with it at the very top, you just take away the 1. And that tells you the valence electrons. So first of all, I want to get this thing equal to 0 on the whole thing because I have a neutral charge. Well, let's draw our atom. So I'm going to have a C, and I'm going to have an F. Now again, I'm going to take care of the outer first. I only have one line, but I can put 6 dots. And what would happen with this one? Well, 1 line plus 6 dots. What is 7 minus 7? 0. So I would basically have to do the same things on here to make it neutral. Now, carbon needs 4. How many lines do I have around my carbon? Well, I have 4. Which means, do I have to add anything to it? No, because it makes it equal to 0. So this one is actually the correct drawing of this. If I look around my central atom, you notice there's no dots. No dots makes this not or non-polar. Now what does polarity mean? Well, if you remember the water, you'll notice it kind of like was shaped in the V. That's what those unbonded electrons do. They kind of mess with your bonding angles. Now let's go ahead and do another one. So now you're going to notice we're kind of using concepts that we've went through before, and that's kind of helping us with drawing the structure. Let's go ahead and do another one. Let's go CO2. Okay, we go ahead, we do our C, we do our O. C is 4, oxygen is 6. That's going to equal, hopefully 0, because again, it's a neutral atom. I can notice, according to this, my central atom is going to be the smallest amount, which is carbon. And at the bare minimum, I'm going to have these lines here. Now, if I go around and do what I normally would do, I would do this. I'm going to take care of the outers first. Now, there's going to start being a problem with this because we are, again, aiming at being neutral, and we are going to notice that that's 1 line and 6 dots. Unfortunately, that equals a -1. We are not going to want to mess with that because that doesn't really work for me. We want this equal to 0. So the next thing I'm going to do is I can do this, then do this. What that does is it reduces or raises up your charge. So if I take a look here, you're going to notice I have 2 lines plus 4 dots, and what does that equal? 0. So that actually works. But I also know I have to take care of this one because it's called symmetrical. So you're going to notice my oxygens are both neutral. Now what happens with the carbon? Well, now I have 4 lines. No dots. That equals 0. So now I have my neutral atom. That is actually the correct structure for this. Now if I take a look around my central atom, I don't have to add any dots around it. So right now, this is going to be called non-polar because I have no dots around my carbon. Maybe you can start seeing my little pattern with this. Now let's go ahead and do another one. Now this takes practice, so you're going to have to start, showing me how to do this on your own. It's going to be a little bit different than having to do it before. Let's go with this, OF2. Well, again, I have O, then I have F. Again, repeat, repeat, repeat. Same setup. Oxygen's still going to be my central atom. F's are going to go here. I'm going to draw my connector lines because that's what I always do. If you don't draw a connector line, you're going to have these all floating in outer space. Just make sure that you're just writing the two of them. Don't get funny and start adding more to it because that doesn't work. So again, I'm going to take care of the outer. And you're going to notice, even before drawing it, that if I have something that looks like this, that should equal 7. So I got one line and 6 dots. So the fluorine's taken care of. Now how many lines do I have on my oxygen? Well, now I have 2. That's not going to work. I want the whole thing equal to 0. But what I have to do in order to make this equal to 0? Again, I took care of the outer to take care of the inner. You're going to notice it's going to start kind of look like H2O. And then I'm going to have my 4 dots here around my central atom. And that's going to equal 0. As far as classifying unpaired electrons around my central atom, it is called polar. That kind of gives you a hint on what we are doing. I am going to want you to do the second part, which is actually going to be advanced, but you're going to notice that it is the same procedures. I still do the same things. We'll see it in expanded octets.